This week we're going to cover actually 2 chapters in this book. They're really not that hard of a chapter, so I thought we could get through that way. So let's just start with chapter 1, monitoring the weather. The first thing you've got to understand is what are some of the basic characteristics of the atmosphere and the weather. So if you were walking outside, how would you describe the weather? Because weather is what's happening now. It's not what's happening in the future. It's not what happened in the past. It's what's happening at a given point in time. So if you walk outside right now, you're probably very concerned about the temperature and maybe if it's raining or not. Is it cloudy? How much the wind's blowing? These are just some of the variables we're going to talk about in meteorology. In order to understand meteorology, you've got to understand what influences these different variables. So the first 2 weeks are just going to introduce some of these very, very basically of the whole atmosphere. Climate, on the other hand, is something much longer range. Climatology really is a whole bunch of stuff coming together to describe putting boundaries on what the atmosphere can do. So one of the things you've got to understand in meteorology is meteorologists deal in universal time, Zulu time, Greenwich Mean Time, whatever you want to call it. It's basically whatever the time is in Greenwich, England, 0 degrees longitude. That's the time that meteorologists, everything is referenced off of around the whole globe for meteorologists. So what does that mean? For example, if Eastern time is 7 a.m. and then Central would be 6 and so on, there's 4 different time zones in the U.S. So if we go to the universal time, at Greenwich, England, at 7 a.m., if the time over there would be noon, it's 5 hours time difference between us and Greenwich, England on standard time, 4 on Eastern Daylight Time. So right now, for example, if you looked at a weather map, we're going to look at one here in just a second, you can find the time in Zulu time written on it. And we'll look at what that means for each time zone in the U.S. Part of a weather map, a surface weather map, is drawing fronts, drawing low pressure systems. You may have seen these on TV all the time. Well, one thing to learn right off the bat is that the low pressure systems have winds that blow counterclockwise. So they're moving opposite of the hands of a clock. So they're going like this. And there you can see. See if we go back here a minute. And with that, high pressure is clockwise. Now here is the symbol for a cold front. Cold fronts basically are triangles and they're in blue. Warm fronts are semicircles and they're in red typically. So a cold front, all it is saying that if it passes your location, the temperature is going to be colder and drier air. A warm front passes you, it's going to probably get more moist and it's also going to warm up. We're going to understand a whole lot more about these with time. Another thing, the atmosphere is 3-dimensional. I'm going to stress that a lot in the weeks ahead. So what does that mean? Well, that means, for example, that if a warm front's coming at you, clouds are going to be out ahead of that warm front, maybe start with some cirrus and maybe some higher mid clouds and eventually lowering down in rain with stratus clouds. With a cold front, probably more abrupt. Warm air is being pushed up by it, and you get some thunderstorms maybe or some intense showers along it. So with that, I wanted to show you a surface weather map for today. Surface weather map today has a pretty intense low up over the Hudson Bay. And again, winds are counterclockwise around it. If they're counterclockwise around it, think about it, they must be coming out of the west across Ohio right now. And there's the front right there just on the doorstep to West Virginia. And temperatures are fairly cool back here. They're in the 40s, even some 30s back in northern Canada here. We're going to talk about air masses. Air masses are basically just large areas with the same type of air, either warm and humid, cold, dry, cold, even a little bit humid. They can form over areas where all conditions are the same. So in Canada, you're going to get cold, dry air masses. If you have an air mass that forms in the southeast, off the Florida coast, for example, you got pretty warm water out there. It's going to be a warm, humid air mass. So these are just some of the types of air masses, just some observations of the weather that you're going to be looking at through this course. We use all kinds of different tools to observe the weather. And one of them is GOES satellite. And GOES satellite can show you a tremendous amount of information. One of the things it does best is to look at what I would call an actual, like if you were looking at it from the sky, for example. Alrighty. Let's see if we can get this back here a minute. And we'll look at, there's a whole kind of sectors for it and everything. So with geocolor was basically any time of the day. You can see this clouds. When it's daytime, they're visible. That would be what you would see. At nighttime, they're more of infrared, looking at more of the different cloud heights. But you can see they're moving across from the east down here in Florida and across the Caribbean, moving to the northeast here. Well, remember we saw a cold front? Well, there's your clouds right with that cold front. And then there's clouds out over the Pacific and out over the Atlantic and more clouds out over the Pacific and all. So we could look at various images just with this. And I said I can zoom into all kind of stuff. But let's just take one other image. We'll see if there's any lightning out there. Satellite also detects lightning. And by doing that, it can describe where some thunderstorms might actually be. And guess what? I see some out in Kansas and across Missouri there, southern Missouri. Down in the Caribbean down here, some more out in Texas. And you can see the areas of lightning there. One other aspect is just looking at radar as another means of observing the weather. So here is for Charleston, West Virginia. And it's basically showing a line of showers well out ahead of the cold front that we were just looking at, but lining up pretty nicely with the satellite. And if you combine these two images, you really get a lot of information. You can see where the heavier showers are compared to the different cloud types you're looking at and all. So this is really just an example of just beginning to observe, beginning to understand just a little bit about the weather. So we'll move on here in the next chapter to a little more information.